Okay, I'm back, and now we want to talk about the carbon dioxide cycle, and it's also called the carbon cycle. So the idea of where does carbon dioxide come from and where does it go? So let's first talk about any planet. For any planet, carbon dioxide comes out of volcanoes, goes into the atmosphere, can be washed out of the atmosphere into an ocean, and then it can be precipitated as limestone, and then the limestone can be subducted back underneath the continent where the carbon dioxide can come out again. So this cycle will occur on any planet that has oceans, liquid oceans. Okay, on Venus, though, the problem is going to be it doesn't have the oceans. So what's going to happen is that the carbon dioxide is just going to keep accumulating in the atmosphere. The volcanoes, they keep erupting. But the carbon dioxide, there's no way of removing it, so it just keeps getting thicker and thicker in the atmosphere. Now, on Earth, we have two other mechanisms. So animals and cars and factories produce carbon dioxide. So that's another source of carbon dioxide in our atmosphere. And then plants absorb carbon dioxide. So now let's talk about Venus. So Venus is about the same size as the Earth, which means it should be just as hot on the inside, which means that it should have plate tectonics and it should have volcanoes. But it doesn't have the plate tectonics, so we'll find out why here in just a moment. So atmosphere is going to be composed of carbon dioxide, a very, very thick atmosphere of carbon dioxide, because there's no mechanism for removing carbon dioxide from its atmosphere. Temperature, very, very hot because of the runaway greenhouse effect. So the idea that sunlight can penetrate the clouds, but then it heats up the surface and then is re-radiated as infrared light, and then that infrared light can't get back out through the clouds. So that's why it's so very hot on Venus. Its oceans have boiled away due to the intense heat. And then it doesn't have plate tectonics because there's no water in in the rocks, so that when they try to be subducted underneath the continents on Venus, it just doesn't work very well. These lithospheric plates are so stiff that they don't bend. And so that's the reason why the plates basically don't move around on Venus. Mars. So some properties of Mars: very small. It's only half the size of the Earth. That's the major thing that influenced Mars. So it's so small that it lost its heat, lost its plate tectonics, its volcanism decreased, so less carbon dioxide in the atmosphere, which means that its atmosphere got thinner and thinner. And also its magnetic field went away because it cooled off so rapidly. And then the solar wind from the sun blew the atmosphere off the planet. So it has a very thin atmosphere, only 1/100th the atmosphere of the Earth. And you can also see it does have large swings in temperature, and that's because it has a very thin atmosphere. I would like for you to know about why is the surface of Mars rusted. so go back in your notes and look that up. I would like for you to know, be able to recognize those dry river channels, and then what does that imply happened on the surface of the Earth, on the surface of Mars in its past. And then the Valles Marianus, I'd like for you to know what created the Valles Marianus. So here's our summary of the terrestrial planets, and also make note of why did it evolve the way it did. And so here's our history. So the moon is a result of a collision between the Earth and an object about the size of Mars about 4.4 billion years ago. And then that debris went into orbit and it formed the moon. Let's see. Initially, Mars and Earth and Venus, they all had oceans. And they received that water from the impacts of comets and meteors, and also from volcanoes. So all of those produced water in the atmosphere. And then as that cooled off, it gave each of these planets oceans. But on Venus, it was too close to the sun. And so its temperature was a little bit higher than the temperature of Earth. And so that meant that its oceans began to evaporate, to boil away due to temperature. And then without the oceans, then there was no more production of limestone. So there was no mechanism for removing carbon dioxide. So the atmosphere just got thicker and thicker, and then because of the greenhouse effect, the temperature got hotter and hotter. On Mars, it also got hit by an object 4.4 billion years ago, but don't worry about that. The main thing I want you to see about Mars was so small that it cooled off rapidly, and so its plate tectonics shut down, and the number of volcanoes erupting carbon dioxide decreased, so that its atmosphere got thinner and thinner. Also, its magnetic field went away because as it got colder and colder, there was less metallic materials going around in circles inside the core, and so its magnetic field went away. And without that magnetic field, that was what was protecting it against the solar wind. And so its atmosphere was actually blown away from the solar wind of the sun. And then its oceans, okay, as the atmosphere got thinner, then there was less pressure holding the water down, and so the water began to evaporate. All right, so now we're going to take a break, and when we come back, we're going to talk about planetary meteorology.